it's kind of an important one because you'll see it on the free response a lot. I know I said chapter 2, and yes, that'll definitely be on the free response, but usually there's also like maybe 2 terms from chapter 4. So last year, I want to say it was either last year or the year before. I know somatosensory cortex was on there. I think motor cortex maybe was on whatever your somatosensory wasn't. And then last year, basilar membrane was on there. And I saw a lot of memes of like no one knew what it was. So pay close attention, okay? So sensation and perception. Okay. Should I use the mic?
Yeah.
Hello? Hello. Hold on. Sensation is when we sense. Yes, when we take in input from the environment, right? How do we sense things? Give me one example. Touch, smell, seeing, hearing, and taste. Okay, so those are the 5 senses, which you guys have known for a long time. Perception is when we, what?
Process.
Interpret it and process it, right? So what's an example where someone can sense, but they can't perceive correctly? Do you remember?
With the hat, right?
Yes, with the hat.
Yeah,
Retro?
yeah, no.
Who?
Retro? No,
The one that he couldn't distinguish between objects and like what they were.
Prosopagnosia and agnosia, right?
Or in the book when he was holding a rose and he said it was like a circular thing with the stick attached to it.
Yeah, exactly. So think of the man who mistook his wife for a hat. He couldn't identify like facial features. I mean, he could see the shapes and everything, but he couldn't tell that it's a face. So what do we call that? Prosopagnosia. And then what do we call the inability to recognize objects? Agnosia or visual agnosia. Okay, good. Absolute threshold. So remember that demo we did with the music? Which one was absolute threshold?
When you hear it,
The minimum stimulus strength that someone
can hear.
can detect or hear or see or whatever. So that's when you had no sound, and then I kept turning it a little bit higher, and the second they noticed the sound, it reached their
Threshold.
absolute threshold. When else do we see the word threshold?
When you change it.
So dendrites take in information. Soma says fire only if the stimulus passes the threshold. So that's what we're talking about. So if it's not a strong enough stimulus, if it's not loud enough, the neurons are not firing, and that's why you don't hear it. Clear?
Mm-hmm.
Okay. What's just noticeable difference? Just notice the difference. So that's a mnemonic, but what is it?
The smallest difference in the stimulus strength that someone will notice.
Very good. So this is where the music is already playing, and what does someone notice?
The change in volume.
The change in volume. So you have to be clear that you say the smallest difference in stimulus strength. Because I could say you change a stimulus, great, you change from one song to another song, of course people are going to notice it, right? But stimulus strength means the volume or the brightness, or if the taste it's stronger, right? Or less strong. It could go both ways. It could go lower or it could go higher. But the second you notice that change, you've reached your... No, change is just noticeable difference. The second you notice something is absolute threshold. Okay? All right. Signal detection theory. So this was the idea that, do we just notice everything all the time?
No.
No. Why is it that a mom could sleep, through wind and, rain and thunder, but then if she hears her baby cry, she wakes up?
Because we're like conscious.
Selective sensitivity, and so that shows us that, we'll hear certain things if they're important to us, right? So whether or not we detect a stimulus, there's a decision-making process. It's not just like you detect it or not, right? If there have been a string of robberies in your neighborhood, what's going to happen? Every little sound you're going to notice, right? You see the difference there? Mm-hmm. So signal detection theory says that detectability depends on decision-making. Yeah, it depends on what's important to us. Yes, Diana? Availability heuristic relates, okay? Because when you're making that decision of what you heard, you're going to base it on recent events, right? But the fact that you heard it just shows like selective sensitivity. Yeah, but yeah, good point. Okay. If the stimulus is present and you say it's present, what do we call that? Hit. Good. If the stimulus is present but we don't notice it?
Miss.
Miss, like we missed it, right? If the stimulus is not present but we say it's present? False alarm. Daily fire alarm, right? And then if it's not present and we say it's not present? Correct rejection. You rejected it correctly. Yeah? Okay. Subliminal perception, you take in information without realizing it. Is it very like influential?
No.
Not really. You know, maybe a little bit, but not really. Okay? It's more just fun.
Could it be
Weak effects. Yeah.
Could it be influential like afterwards, like when you thought of something you automatically think of?
Could be. Could be. Yeah, it's got like weak effects. That's all. That's all you need to know. Okay, sensory adaptation. What is that?
When you're exposed to a stimulus,
So like the trash, right?
Yes, the trash. You walk in, you smell the trash. Oh, it smells disgusting. After 3 minutes, what?
Stop.
You don't smell it anymore. Okay, like the Febreze commercials, right? Or like it could be brightness too. What do we call it when you walk out of the movie theater and it's daylight, and at first it's really bright, and then you get
Light
used to it?
adaptation.
Light adaptation. Good. What is dark adaptation?
When you walk into a movie theater.
You walk into the movie theater and it's dark if the movie already started, right? And you can't see anything at first. Or when you turn off the light at home, you know, when you go to bed at night. And everything is dark, but then after a few minutes, you start to see, you get used to it. Okay. What is habituation?
oh, it's where you're exposed to a stimulus, but you stop responding to it.
That's right. Good. So you're exposed to a stimulus, you keep being exposed to the stimulus, and over time you stop responding. It's very similar, and you know, it's. I don't believe it's in our book. It wasn't in our book when it was on the free response a couple of years ago, but you know, it's another term that they could put on there, so it's worth knowing. Okay, so now we're on to sight. Okay. So how do we see what comes in through our eyes?
Light waves.
Light waves, good. And what does the wavelength tell us? Not brightness?
Energy.
Color.
Oh.
Remember wavelength, colorful waves, right? And then what does the height tell us?
The brightness.
The brightness, because height rhymes with?
Right.
Bright. And what do we call the height?
Altitude.
Amplitude, which rhymes with?
Alt.
Altitude. Good. Sometimes we confuse the mnemonics, but you should be okay, even if you do. On multiple choice. This would probably not be a free response question anyway. Okay. All right. Saturation tells us what? The richness or the intensity. The more white is mixed in, the less saturated. The less white, the more saturated. Good. Red has a higher or lower wavelength? Higher. And then violet has a
Lower.
Lower. Good. Do we see like all the wavelengths?
No.
Nope. It makes you wonder what we're missing, right? Okay. All right, the eye. Here we go, the eye. So, first, you have this outer clear thing. What do we call it?
Lens.
Cornea. Cornea, right? And what does the cornea do? It protects the eye, right? Good. Then, where does the light travel? Pupil, right? Which is what?
It's like an opening.
It's a hole. Yeah, it's the black part, and it's actually a hole. How does the iris get involved? It opens or closes the pupil, so the iris is actually a
Muscle.
muscle, right? It's a colorful muscle. And when it's really light, what does the iris do? It
Close.
squeezes, it closes the pupil because it's like, whoa, too much light, right? When it's dark, the iris
Expands.
expands it so that it lets in more light, okay? After the pupil, where does the light go through? The lens.
Which
okay?
is the cones and
the lens
rods.
is that curved shaped circle. And what does it do? It accommodates, which means to focus, and it also flips it upside down. If you think of a spoon, anything curved is going to flip it upside down, right? And then finally, it hits the back of the eye, which is called the retina. And what does the retina contain?
Cones and rods.
Rods and cones, which are called receptor cells for sight, right? Tell me what the rods do. Rods.
No, rods. Black and
Nighttime?
white.
Peripheral vision.
When you're at
Peripheral and
Only see black and white.
black and white. What was the mnemonic?
The robber
The
missed.
robber holding a rod in your periphery, right? And he's gonna get you, and the rod is black, and it's nighttime. Okay? All right, and then cones.
Snow
C
cones.
for cones, C for color,
Color.
and what else?
Their color. They see color.
Daylight and
Color.
Cute.
acuity. How do you get the best visual acuity? How do you look at something?
look at a certain
Directly at it. What if it's dark?
turn your head.
Then you turn to the side so that your rods can look at it. Okay, good. Good. What's the phobia?
It's a little.
It's the area of the greatest visual acuity.
Cones. So it's the area of greatest visual acuity. And remember, cones are involved in acuity, so it's a lot of cones. So remember, I think we had a mnemonic if someone has a phobia of cones. Like cone phobia. Conophobia. I don't know what you would call it. But we'll call it that. What's the optic disc?
What's the blind
The blind spot. The blind spot. Why is it blind? It has no rods and cones in front of it. Why?
Because it will block the optic
Because it would block the optic nerve, because that's what comes behind it, right? And where does the optic nerve send information?
to the brain.
To the brain, right? Okay. We'll get to the pathway in a second. We'll go over that. So we're good on all the parts of the eye. What's the clear protective?
Cornea.
Cornea on the outside. Then it goes through the pupil. Okay. What controls the pupil?
Iris.
The iris is the muscle, and then behind the pupil it goes through the lens, which flips and accommodates, and then it hits the retina, which contains rods and cones. What do rods do? Night, black and white, peripheral. Good. What do cones do? Color, daylight, acuity. Good. Where's the area of greatest acuity? Phobia. It has a lot of
Cones.
cones, and it's directly in the back. Okay, and then what's the blind spot? Optic disc. Why is it blind?
No rods and cones.
No rods and cones, because otherwise it would block the
Optic
optic nerve, which takes information to the
brain.
You got it. Good. Okay. Nearsightedness. What can you see? Near. Assuming you're not farsighted too. Okay, and what can't you see?
Far.
Far. Okay? Farsightedness. You can see
Far.
far, but you cannot see
Near.
close. What tends to get worse as you get older?
Farsighted.
You tend to become farsighted, which is why parents use reading glasses, because they cannot see close. Both, honestly, both get worse. Everything gets worse. Everything just goes bad. Aging. Okay. All right. What comes first, bipolar or ganglion?
Bipolar.
Because B comes before
G.
Good. Okay. All right. The pathway. Go like this. These are your optic nerves. Okay. Say optic nerve. Optic chiasm. Thalamus.
Occipital lobe.
Occipital lobe. Again. Optic nerve.
Optic chiasm. Thalamus. Occipital lobe.
What does the thalamus do? Relays sensory information. So once it goes to the thalamus, it's like, oh, that's sight. So let me send it to the occipital lobe, because that's where vision is processed. Okay? Good. It's coming back to you guys? Okay. Okay. Pupil and weasel. Remember the cat?
Yeah.
Because weasels are like cats. Sort of. All right. So, quick review. They attached electrodes to cortical cells in the occipital lobe. These are just cortical, means cortex, so the outside, that's all. Okay, so they attached electrodes and they put in front of them lines, right? They showed them vertical lines, They showed them horizontal lines, and they showed them diagonal lines. And what did they find?
They specialized cells.
They had special cells. Some of them only responded to
Vertical.
vertical. That was the one they tested. So,
Yeah.
so they responded a lot. And then when they did horizontal, they
No response.
didn't respond really. And then diagonal was kind of in between. Okay, so this shows that we have feature detectors, which are
Specialized.
specialized cells. That's all, right? For every sense, but that was the proof for vision.
Thanks for filming.
Okay. We did that. Okay, ventral stream and dorsal stream. So remember, so once it's in the occipital lobe, then it goes somewhere else so that we understand what it is. So it starts in the occipital, okay? What's the ventral stream? What was the mnemonic? Venti. What would you like from Starbucks? I would like a venti. So that's the what pathway. What shape is it? What color is it? It's the what pathway. Okay? And venti, we like hot temperature, right? So where did it go from the occipital to the temporal? And then dorsal, what's the mnemonic? Where is Dory? So it goes, so what's the question? It answers where. So that's like movement. It helps us sense movement because we can't see movement unless we know where something is, right? And then we said Dory is looking for her parents, so parietal. So the dorsal goes from the occipital to the parietal, and it's the what pathway? The where. The way I asked is probably really confusing. And then the ventral goes from the occipital to the temporal, and it's the what pathway. Clear? So if you get stuck, just think of the mnemonics. Ventral, what'll you have? What'll you have, venti, Starbucks? Dorsal, where's Dory? Okay? Okay, visual agnosia again is what?
Inability to recognize objects.
Inability to recognize objects. Prosopagnosia is inability to recognize faces. Good. Plasticity, as we learn new things, what happens? Our brain physically changes shape. I just think of like melted plastic, and you could shape it into anything. That's what I think when I think of plasticity. Okay? And then what about, oh no, we'll get back to, I thought neural pruning was on that slide, but it's not. Okay, so color again. Wavelength gives us color. Amplitude gives us brightness. And purity is a measure of saturation. If it's less pure, that means white is mixed in. Okay? Color mixing. When subtractive versus additive, what are you subtracting or adding? Light. So with subtractive color mixing, when you color mix, you end up with
more. You end up with white light. It depends.
Subtractive, you're taking away light.
Oh.
You end up with dark black. It's like paint, right? And then additive color mixing, you end up with white. Yeah, because you're adding light. So think of subtracting light versus adding light. Clear?
Mm-hmm.
Okay. So that's additive because you add, and so when you add all three, you end up with white. And then subtractive, when you add all three, you end up with black. Good. Okay, the theories of color vision. Trichromatic, what does tri mean?
3.
And then chromatic color. What does this theory say?
We have 3 color receptors.
You have 3 types of
Color receptors.
color receptors, but 3 types of cones, right?
Mm-hmm.
What were the colors?
Red, green, blue.
Red, green, and blue. Okay, so it's not the primary colors. It's not yellow. Red, green, and blue. And then how do you get the other colors?
Mix them.
Your brain mixes them together. And proof for that is color blindness. When you have people that are dichromates, what does di mean? 2, and so they can't see the other colors that the other one needs for mixing. Okay? What's a complementary color? The opposite on the color wheel, right? Mm-hmm. The opposite. So opposite of red is green, right? Opposite of yellow is purple, bluish purple. Okay. What's an after image?
It's a complementary color.
Yes. So if we stare at something for a while and then we look away, we see
an image.
that figure, but in the complementary color. So if we stare at this red heart for a while, when we look away, what should we see? A green heart, and that's called the after image in the complementary color. You got it, Giselle. It's okay. All right. Okay, so the opponent process theory says that we have opposite opponent, right? Opposite color pairs, and the when you look at one, the other one is firing too. The opposite is firing, and that's why we see the after image. So after image is proof for opponent process because it's the opposite color that you see. Is that clear?
Mm-hmm.
Okay. All right. Which is right?
Both.
Both of them. Which happens first?
Try.
Trichromatic happens first because at the cone level, it's like in your eye. And then opponent processing happens further in your brain. Good. Color and behavior, what is red associated with? Attraction, danger, right? So why? Blood,
Evolution.
evolution, poisonous animals, you know, a lot of times have red. And so we think, you know, we're attracted, but it's really like our heart rate going up because of danger, and we're probably misinterpreting it, okay? What happens when you take a test and it's on a red Scantron?
Anxiety.
It causes more anxiety. Yeah, so you saw the AP when you did the pre-administration, it was like blue, right?
Mm-hmm.
So you're good. See? All five, all around.
was purple.
Huh?
You said we have to grade it for in a red color and a red pen.
Oh, on my spring break packet? Yeah, if you want to grade it in purple or green, I'm okay with that. I grade in purple. Partially because of that, because I heard it like creates anxiety in kids. He does do purple, yeah. It's his favorite color. All right. Okay, cool. All right, a reversible figure is what?
That's two different.
A drawing that can have two
The old one.
Images.
interpretations. Okay, good. And we generally, what do we notice first?
What it applies to us.
What applies to us, or what
Schema.
What,
Our schema is.
what what we can relate to, our schema, right? So when the student asked me if I noticed the old lady first, made me wonder. All right.
Yeah.
So those are some examples. That's another example. Okay. These are ones that I feel like they're very likely to be on the test, and I feel like my students sometimes forget them. So pay close attention to them. Perceptual set, you have a set of expectations, and that affects what you see. Okay? So if you expect to see something, then you might see something that fits with your expectation. Inattentional blindness, remember the moonwalking bear?
Oh yeah.
Okay? So what is inattentional blindness?
It's where you don't see things because you're focusing
You don't see something right in front of you because you're focused on something else. Okay, and that was on the free response a couple years ago. The girl was driving from like New York to California, and she gets into an accident. And then the term, explain how each of the following could have like helped or hindered. Be careful. Sometimes some are just help, and then they're hinder. So just read carefully. I think that was under hinder, unless they just had it combined. But how would inattentional blindness hinder her trip?
She probably was on her phone.
She was focused on her GPS and therefore didn't notice the guardrail that was right in front of her. That was what it said, guardrail. And so she ended up hitting the guardrail because of inattentional blindness. She was focused on the GPS instead. Okay, sorry, that was a little repetitive, but better to be repetitive than not. And make sure you always include the definition and the term itself. You always include the term.
Incomplete
And
sentences.
the person's name. I think her name was Ashley in that one.
Incomplete
She was
sentences.
on the phone talking to her parents.
Like,
Oh my
Right,
God.
that's what it was. She was on the phone talking to her parents. And so you could say, you know, with inattentional blindness, she was focused on the conversation with her parents, and so she didn't see the guardrail that was right in front of her, which caused her to, you know, to hit it.
Why is it getting closer?
Okay. What?
Oh no, good.
Oh, okay. Feature analysis is also known as
Bottom up.
bottom up. Just think of the words. Feature analysis. You're analyzing the features and then noticing the whole. Yes.
As a mnemonic, could you just think of feet as features?
Oh,
So
sure.
bottom and then
Yeah, I
up.
like that. So Carmelita just said, think of feet when you look at features. So bottom up. Feet are at the bottom.
I like bottom.
I like that. Good. Okay. So, so feature analysis. You notice the first what? The parts, and then the whole. What about top down?
You see the whole first.
You see the whole first, and then you notice the parts, and you check yourself, and then you're like, okay, yeah, that's the whole. So what proves bottom up? Hubel and Wiesel studied feature detectors, right? The fact that we have cells that notice just this line, right, shows that we're noticing parts. And then what proves top down?
Subjective contours.
Subjective contours. So what do we see when we look at this?
A triangle.
A triangle, but is there really a triangle there?
No.
There's not. There are no 3 lines. Everyone always is like, yeah, there are. I'm like, no, there's really not. So we're noticing a whole, even though there are no parts. No, because the parts would be the lines, right? So that proves top down. It proves top down because it's clear we're not using bottom up. Because otherwise our feature detectors would notice the lines, but there are no lines. Clear? Okay, good. Okay, Gestalt Psych. So again, Gestalt means shape or form. The whole idea behind it is that the whole is greater than the sum of its parts. Okay, and Gestalt means like everything we see or take in, we like it very simple. That's right, we like it very simple. So of all the Gestalt principles, simplicity is the one that is like most Gestalt. Okay, and you might be asked that. The phi phenomenon. Remember the flip book I showed you guys?
Yeah.
So what is the phi phenomenon? It's an illusion where when we see images
In
that are
motion.
quickly one after the other, we see the illusion of
Motion.
motion or movement. Okay, good. So these are like those neon lights, you know, like they're pouring a beer and first it's like this, then it's like this, then it's like this, right? Or the flip books, right? Or TV in general, it's actually shown in frames and it's just really, really fast, so we see it as movement. Clear? And movies and stuff like that. Okay, here are the 6 Gestalt principles. Figure and ground. Depending on what we see as the figure or the ground, we're going to see something different. And our brain likes to kind of separate it into figure and ground, right? So if we see black as the figure, what are we looking at?
Faces.
2 faces. If we see white as the figure,
Face.
we see a vase, right? Good. Proximity, what do? We group things that are close. Proximal, right? Close. So we see a big square, right? Closure, what do?
We fill in the line.
Our brains can fill in the blanks, right? Imagine if our brains couldn't. And then you looked at this, you wouldn't know what you're looking at, right? Yeah, because thankfully we have closure, right? All right. Similarity, we group things that are similar, okay? So what are we grouping here? What are we grouping? Dark versus light, right? We could group by color. Usually we group by color, okay? Simplicity, what do we see?
Shapes.
2 shapes, because it's more simple to us to see the rectangle and the triangle than this weird thing that we don't have a name for. Maybe if we had a name for it, linguistic relativity theory, we would see it.
Ooh.
Right? Isn't that cool when we could tie in all the chapters? So much fun. Okay, continuity. We see things that continue in smooth paths. We like smooth paths. Okay? All right. Perceptual hypothesis. So what's a hypothesis?
Guess.
Tentative statement between.
Yes, for chapter 2 that is right, but a guess, right? Yeah, but for chapter, that's a perfect answer for the free response. So it's a guess. So we're constantly making guesses about what we see. Okay, perceptual hypothesis, not to be confused with perceptual set. We have a set of expectations, and that affects what we see. I feel like perceptual set, like, I don't know why people forget it, but just remember, set of expectations. I feel like it could be on the test. Okay. And again, we see what we expect to see. So when we're proofreading our papers, we don't expect to see a typo because we know what we meant to say, right? So we don't notice the typos because we expect, the sentence to be a certain way, and right? That's why it's good to hand it off to somebody else for proofreading. Yeah.
Some guy says, how does this relate to the reversible figure of the mouse in the old man's face?
Okay, so how does it relate to the reversible figure of the mouse in the old man's face? So remember, I told you guys that if they keep showing mice, like a mouse, what's this? A mouse, a mouse, a mouse, and then they show you that figure, that reversible figure, you're expecting to see another mouse, so you're going to see a mouse.
With the fruit.
If they showed you old men faces, old man face, and then they show, you remember which reversible figure I'm talking about?
Yeah.
And then they show you that mouse one. Remember, it was like the tail was like the chin of the guy. Yeah, and then the glasses were like the ears of the mouse. So if you see a bunch of old man faces prior to that, you're going to expect another old man face, and that's what you're going to see. Clear? How are the study guides coming? Good? That's okay. As long as you can read it. Okay, depth perception, they really like to ask about, really honestly this whole chapter. But depth perception helps you what? See how far away something is, okay? So like on the AP test a couple years ago, they had retinal disparity. And it was like, oh, that was the same one with Ashley and the guardrail. So explain how each of the following could help her in her drive. Retinal disparity was on there. So you don't have, for that one, you don't have to say like, oh, in each eye there's a slightly different image. That's not what they're looking for. What does retinal disparity help you do?
Distance.
Judge distance, right? It's a depth perception cue. So you would say retinal disparity helps Ashley perceive distance or depth, and that would allow her to judge what?
If she's gonna hit the guardrail or not?
Yeah, how far is between her car and the guardrail, or the car in front of her, and that would allow her to avoid an accident. Clear? So just, always think of the term, but think of the scenario and how it would fit with the scenario, okay? All right. So binocular cues, what's bi? Two. So there are two binocular cues. There's retinal disparity. This is the one where if you close one eye and then close the other, you see a slightly different image. The closer the thing is, the more or less disparity. The more disparity. Right, meaning it's a bigger difference, right? The farther it is, the less disparity. You get what I'm saying?
Yeah.
Okay. So if it's up really close, then you have a lot of disparity, and that just helps you judge distance. And then the other one was convergent.